Greetings, I'm Mark Hall, AE0ME, with our Field Day 2020 education session for the St. Louis and Suburban Radio Club. This video is a guide to help you learn how to quickly tune a dipole for the lowest SWR centered at your desired frequency of operation. In this example, I cut a dipole longer than usual. This allows us to operate it if it needs to be longer or shorter than expected based on local conditions. Instead of cutting this wire when tuned, we will simply fold the wire and wrap it back on itself so we can lengthen or shorten it as needed, either now or in the future. I will hang the dipole, measure the frequency where the SWR is at a minimum, lower it, adjust it, and then hang it back up. Let's start with getting our antenna mast set up. After the antenna mast is set up, we can assemble and hang our dipole. I've attached ring terminals to one end of each leg of the dipole to allow easy attachment to a 1-to-1 current balun. I have a paracord attached to a ceramic insulator at the other end of the dipole leg so I can easily adjust the dipole without much hassle. The paracord is tied to the mast, runs through the carabiner at the top of the mast, and back down to allow us to easily raise the dipole. As you can see, I've got a nice baggy cut. I have one for each band from 6 meters through 160 meters. They are all labeled with the same information about the band. Each band has a different color of tape for easy identification on the bag and at each end of my dipoles. I want to show you how I've labeled this. I've cut the dipole for 18 feet. At 14 megahertz and the ideal height, it should be 16 feet 9 inches, and 14.35 megahertz, it should be 16 feet 4 inches. This dipole is definitely cut long. I will pull this out and show you how to adjust it. The reason we are stretching out our dipole to measure it is because we need to know the initial length of the dipole legs before we hang it up. Then we can hang it, find the frequency where our dipole has the lowest SWR. If we're very lucky, or this has been previously tuned and hasn't been changed, we won't have to pull it back down again. Now that we've got those sections stretched out, let's measure them. We won't cut the wire, we'll fold the wire back on itself. We should go from an awful SWR to where we are tuned to nearly 1-to-1 at the desired frequency. Okay, so as you can see, I have measuring tape strung out on the ground, and it runs up the hill there to where the ends of my dipole halves are. So each leg is run. And what I want to show you here is that I have them both here at the end of the measuring tape. So, because I'm doing this by myself, I'm going to try and line these up nicely and neatly. And then, because again, by myself, I'm going to anchor it with the rest of my kit. So what I did is I pre-cut all of my dipoles, so I've got one for every band, and as you can see, we're just going to stretch it out here and come up to the end of the and of course the insulator fell off. We are, and if I stretch this tight, we are at 17 feet 5 inches, or call it 4.5. At any rate, half an inch at these frequencies is not going to matter a lot. A little bit, but we're not going to worry about a lot, because we just need to get it pretty close anyway. So 17 feet 4.5 inches, and where I'm measuring that is the end of this wire that comes through. So this point right here, this distance, is what we're measuring from the tip of that ring terminal to this. That gets us pretty darn close. We could probably just use 17 feet 4 for our measurement, and it'll be really good. So what I'm going to do now is I'm going to attach the ring terminals to my current balun, and then we will hang that up on the mast, and then we'll take our measurement. We're going to take our current balun, and we will go ahead and wire each terminal ring on the dipole to the terminals on here. And then all this does is it connects our coax through a transformer onto each leg of the balun. So all we need to do is just make sure these are loosened just a little bit. And I'm not going to do these overly tight. I just do these because I have them tight enough that they won't loosen unexpectedly. And so I'll just take the ring terminal, and these are, I bought these at the hardware store. This is 14 gauge stranded antenna. It's a UV resistant and weather resistant outer jacket. And then once I can get this nut back on that screw post, that is always the problem with a live demonstration, right? We'll get this on here. And again, hand tight is fine. I'm going to go just a hair beyond hand tight because I want to make sure that my bolts or nuts don't come off of this and I end up losing them. So they'd be a little difficult to find in my grass today. So I'll tighten this up again. All right, they're hand tight, and I'm just barely going to twist this with the pliers just enough that there's just a little bit of tension on them. So now one is on each side, and we will now string them up on here, and I'm going to put a weight on each end. And the other thing I'm going to do is I've got some more paracord, and I'm going to loop the paracord through this and then anchor it off to the side, so that way we've got sort of a slightly sloped V. So we'll do that, and we'll do that time lapse, and then we'll come back and measure it. All right, as you can see, we have the balun now hung at the top of our mast. Our antenna is sloping up and down somewhat nicely on either side. On this other side, you'll be able to see we slope up, and there's our antenna hanging. Our antenna is hanging with our coax down at the ground. I'm using RG8X. The length shouldn't matter as long as you're using a 50 ohm cable. If you remember, the SWR, or standing wave ratio, is how your feed line, which should be 50 ohms, interfaces with the antenna, which should also ideally be 50 ohms. You're tuning the length of the dipole to adjust the impedance of the dipole so it matches the impedance of the coax. If you have a mismatch, that's how the signal gets reflected back towards your radio, measured as SWR. If you have an SWR of 3 or more, your radio may have trouble handling it. Modern radios can usually handle an SWR up to about 3. We'd like to get this closer to 1:1, so that way all your power is being transmitted. To measure this, I have a SARC 110 antenna analyzer, but there are others, such as a Nano VNA. It will give us a plot of performance of our antenna's SWR across the frequency range. MFJ has a device that doesn't graph, but gives you a similar result. They also have a newer version, which is a little more expensive, that does graphing. We will connect the device to the end of the antenna cable. I had originally told you that our frequency band, which I've marked on my package here, we want to be between 14.00 megahertz and 14.35 megahertz. So our frequency is 13.278 megahertz. So we're definitely a little long, which again, I cut it at 18 feet and we need 16 feet, 4 to 9 inches. So we've got to come several inches off of that. And this, I believe, is per leg. So that means we need to come down at least to, if we were going to go with the standard sizes, at least 5 inches. The fact that we're off with this, we have to do a little bit of math for that. So I showed you that we measured this and our frequency was 13.278 megahertz for our lowest SWR frequency. So the math to do this is pretty straightforward. And you're going to laugh at how simple it is, but try it. It works. Because I've already tried this a couple times. We're going to demonstrate this today. You see that my SWRs are awful. Here's the current SWR for the lowest frequency. And now here's the SWR in the band that we want to use. We're well over 2. This is not good. So what you do is you take your initial length of your legs And you can do this for the whole length of the dipole, or you can do it by leg half, as long as you keep it straight. You multiply that times the megahertz of the frequency that's your lowest SWR. So that's going to be 17, and you want to convert this to decimal. So 4 inches is 1/3 of a foot. So we'll call it 17.33. You could give it more decimal points, but it's not going to matter much. So 17.33 times 13.278, which is our frequency, the lowest megahertz, and then divide that number by the desired frequency. So if you remember, we want to be between 14.0 megahertz and 14.35 megahertz. I just picked 14.15 as a point. You can make this a little bit higher, but the math on this, it ends up being 16.28 inches, or yeah, 16.28 feet. So 16 and a quarter of the 12 inches in a foot, that's going to be 3 inches. So I need to take this down, measure it to 16 feet 3 inches, and hang it back up again, and then we'll remeasure and see how we do. I've pulled it down, I've lined up the end. I'm only going to show you the one side, but we'll do both sides. We're currently at 17 feet 4. We're going to adjust this down to 16 feet 3 inches. I've twisted that. As you can see, it's back on the wire a lot farther now, but we are right here at 16 feet 3 inches. So right here, straight up 16 feet 3 inches. So we'll go do the other side and we'll hang it back up again. Our 20-meter dipole is now hanging on our mast, having been shortened to 16 feet 3 inches. This should be pretty close to 1-to-1 right now at 14.15 megahertz. It may be off a bit due to errors in measuring, or just due to being at a slightly different angle. As you may have noticed in the time lapse, I forgot to loosen the tie downs and had to adjust them so I didn't pull the wire longer. That's a big gotcha when you don't cut it. You need to be somewhat careful of its length changing. Tape or a non-metal clip could solve this. By wrapping it back on itself, the electrical length is from the terminal ring to the end of the loop in the insulator. That's the length that we will measure to make sure we're as close to the frequency as we can get. As I indicated earlier, this is not perfect, but it's darn close. We are now at a 1.10 to 1 SWR at 14.174 megahertz. The results on this will be as good as your measurement and your math. My antenna height is probably not ideal. Being higher or lower can factor into it. To recap, measure the initial dipole length. Find the lowest SWR's frequency. Choose the new desired frequency, and then calculate the new dipole length. Then adjust the length of your dipole. This method works if you use the leg length or the whole dipole length, since it's based on the ratios. Just be consistent when using the formulas. This calculation and measurement approach got us to 1.10 to 1 SWR at 14.174 megahertz with hanging the dipole twice, and we can start using it on the second hang. I don't have to pull it back down again. Another thing to consider is your bandwidth and the SWR across your frequency band. This dipole is at 1.49 or lower SWR across the entire 20-meter band. If you're careful about your tuning and placement, you can get very good results across the whole frequency band, and these are well within the ability of any radio to handle it with no tuner needed. Good luck with your dipole tuning. If you have any questions about this, you can email us at info@slsrc.org or fieldday@slsrc.org. We're obviously participating in the field day events, so I doubt we'll be able to answer today, but this is a good exercise that can make life easier to deal with dipoles without needing to measure it, guess how to adjust it, hang it, and repeat this process a number of times. We got pretty close at a 1.1 to 1 SWR at 14.174 megahertz. I hope this works well for you and saves you a whole lot of time. Good luck to you with Field Day and have a great time. 73 from all of us at the St. Louis and Suburban Radio Club.